Any question? Yeah, please there. Just a minute, because otherwise online they cannot hear or you.
Hello. Hello. Okay. I have a question about the hybrid modeling. I really enjoyed the presentation. I was wondering if you had looked at or were planning to look at how these structures respond when the moon moves through Earth's magnetosale.
Well, in the tail, the density and dynamic pressure are not that high, so they would not affect the crustal fields, I believe. We have not looked at it, but since the pressure is not that much, then the structure of crustal fields would stay as that has been included in the model. We have looked at it in the magnetosheath. In the magnetosheath, due to the high dynamic pressure of the plasma in the sheath, majority of the crustal fields are compressed down to the surface, but we have not looked at the tail, no.
Thank you.
I have two questions. One is for the blue dot person, and my question is, with this 20 by 20 degree field of view, will there ever be something else that's bright enough beyond Earth, like a bright planet or whatever, or like real bright star that you could actually observe with that thing?
Well, the first and most obvious one is the sun. That limits the phase angles that we're able to observe to the larger angles. As soon as we get too close to the Earth, and we're not able to differentiate between the direct light from the sun and the light through the Earth. The other one that we were concerned about was if, for example, we're landed near the poles, then the Earth tends to be quite low in the sky. So we may also get some stray light from the lunar surface itself. Those were the main two contributions that we're looking at, baffling strategies in order to sort of increase the observational period with those two contributions. But in terms of other solar objects, we haven't considered this yet. I think the intensities are quite different between the light from the Earth and the next brightest object, which is probably Venus or something.
Okay, thanks. And I have a question for the radio telescope, these ALU people. So have you considered a non-regular grid? Of course, you can't do the simplest FFT because non-regular grid will help you with all these grating artifacts. And of course, you can't use the simplest FFT imaging, but you can kind of, just double the FFT grid and just occupy half the cells, so some version like that as a compromise between fully randomized grid or fully regular grid.
So that's a very valid point, and that's exactly what Sonia is working on. So I thought she would pick up the answer there. But that's very valid. So the primary concern with us trying to put this in a regular grid is, of course, the data rate that comes out, right? And the processing required to treat all the antennas. So you can't do individual correlations. But a midway might be achievable, right? Where you have multiple subgrids, maybe offset in interesting ways to basically limit the effect of these grating lobes. But you can't get rid of them altogether because there's some degree of regularity involved for processing power's sake, which does mean that you will always get grating lobes at the higher frequencies. There's no way to completely avoid that effect, I'm afraid. But indeed, yeah, several subgrids working together might alleviate it well enough to circumvent the fundamental problem. But of course, detailed simulations will have to help us with this to get a very clear idea about how bad these effects get and how well we can mitigate them.
Thank you.
Other question? Okay, I have a question for Bernard. Just a curiosity, you spoke about this liquid mirror telescope.
Yep.
How do you think this can advance the performances with respect to James Webb? What about the cost, the feasibility of realizing something like this on the moon?
Yeah, so there are some existing liquid mirror telescopes, and they were developed in Canada by Bora and also in the US. So they could reach 3-4 meters. And so we were looking at the 30-meter class. And actually, that's pointing always in the same direction. First, so we are. It's really a telescope like a pencil into the past. And just because of a bit of the libration of the moon, you can map an area around, but you would have access to a 30-meter, mostly dish collector, well, light collector, not very high precision in terms of images, but really big collector. And so, so we looked at some material that would be working. So we had some small demonstration. So, okay, we thought at something that could be next generation after James Webb, or maybe even they could be used in other wavelengths as well. And so they could also be complementary to what we would do with Lunar or other very gigantic mirror on Earth, but in wavelength range which are not accessible from Earth.
Yeah. Thank you. Thank you so much. Any other question? Okay, if there are no other questions, I would thank so much all the speakers of the session. Thank you so much, everybody.